Hi, in this Unity tutorial, I finally got it together. I got like a situation here where I've made like a Minecraft-like voxel engine here. Let me just jump up in the air so you can see what's going on, where I got hills and stuff like that. And I could remove voxels and add voxel. Okay, and there's different voxel types and stuff like that. And I'm going to show you how I did this. So before watching this video, there's a couple of others in the playlist. So this video comes after the how to make a chunk. So let me just stop the game and whoop, everything's gone because everything was generated through a script. And I'll show you what we got going. We'll start from scratch together. So the first video, before you get to this one, if you want to take a look at it, you can go to omorevision.com and you go to the tutorial section, and here is a chunk of voxels, and here's making just a voxel. So you could see things in order from explain, make a voxel, a chunk of voxels, and there's a bunch of videos here. You could just type search and find what you want to look for. But let's start up that project. So I'm going to open up Unity and make a new project for demonstrating this new thing. So this is a new project, and I'll call it voxel terrain 02 and say create. All right, so here I have my brand new empty 3D project, and I'm going to put this view in the Game Camp Big view. There we go, where I got the thing split up in pieces here. And the first thing I'm going to do is first, let's get our chunk working. So let me save this scene as chunk. Okay, and chunk was something I had in the last tutorial. So I'm just going to bring down the chunk script into my project and the voxel script into my project. And this is what the voxel script looks like. If I open up in Visual Studio, okay, you can get the scripts on omorevision.com in the tutorial section. But here I have the voxel script where the first thing has a couple of helpers here. And, I enumerate the corners, the sides I want. These are the actual textures that are in the material. And then these are the voxel types. It could be grass, dirt, water, leaf, etc. The sides, the voxel, all the data that the voxel is going to store for making its mesh for just the one voxel. And then here's all the stuff for the data that's going to store just to figure out where to grab the texture from for the voxel. And that's the helper region. Okay, then we just have our variable, like we're going to have the mesh data that was in the helper that's going to hold all our data for the mesh that we're going to give to the mesh. If the voxel's on or off, one means it's on. The type of the voxel, which is going to be like what textures get put on the voxel, and the size, and some variables. Okay, so first in the voxel create, in the constructor, we create the voxel where it's full on, and the default voxel type is whatever is passed into the constructor. Here we can grab a corner of the voxel by specifying a corner from the enum corner, and then it'll get us that coordinate for the corner of the voxel. It considers where the voxel is, and then from that position moves off from the center, either minus, 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 plus, minus, minus, etc. Get vertices for a side of the voxel, since each voxel is going to have its own set of vertices. So that's 4 points per side. So if you're getting the back, then I grab corner EFAB. See this little diagram here? That's how I keep track of the letters for each corner. I named each corner a letter. And then, I can get the vertice side for any of the corners. There's any of the sides. There's 6 sides. And then setting the UV for a side, the UV is like the texture mapping. So it's going to say where from the texture am I going to map something on here. So I'm going to basically, based on the texture, if it's dirt, and then I use the calculations of where in the texture I'm going to get. So let's show you the picture of the texture. It's basically like this, where each little square is in a position, and I get the position of the square and use that. So there's the top row, the middle. It's 4 rows, since I have 4 rows of textures in this map. 1, 2, 3, 4. All right. And all this stuff is in the voxel video. Then after I get the coordinates for the low and the high of the texture from the material, then I just actually set those as the UV coordinates. Okay. And here's the voxel type. So if it was dirt, then basically every side of the voxel is dirt. If it's grass, then I have grass dirt on the sides, grass on the top, and dirt on the bottom. And water, leaf, blah, 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 blah. All the other different combinations that I want. All right, so this is setting a triangle side. If I'm going to set the triangle to be on or off. So, if I turn on the back, then I have to get the coordinates and I set the triangles. So basically what I do here for setting, so if a voxel has 6 sides and there's the vertices for each side, I just set the vertices to 0, their value to reference the triangles reference the corners, or they're just going to reference 0 to 0 out so the triangle doesn't draw. Set triangle side with a code. That's a binary code. So it compares binarily the code to see if that particular bit is on or off, to set that side on or off. Here's like if I turn my voxel on, then I just call all the triangle sides and turn it on. Here's if I turn it off, then it's 0. I turn all the sides off. So anyway, that's the voxel class, right? The chunk class also is another video, but basically what the chunk is, it's a set of voxels. So the voxel class is not a model behavior. It has to be used by something. So it's used by the chunk. And in the chunk, we have an array of, here, the voxel class objects, which store the data for each voxel. So a chunk is a chunk of voxels, and the size of this one is 10 by 10 by 10. And for the helpers, I have an event here that's going to fire off once the chunk is rendered, and I could start referring to it from other things in the game. So here in the start, I'm going to get a pointer to the mesh collider of the chunk. So let's actually put a chunk in here. So let's make a material right here and call it terrain map to match the name of the texture. And then here, I'll just put that there. Okay, terrain map, there you go. And that's how it looks like as a square. And then we're gonna put a empty game object in here, empty game object that is, and this is gonna be our chunk. All right, and the chunk, we're gonna tag it as a chunk, add a tag. The reason I'm adding a tag is because when I put my first person controller in there, I'm gonna know that I clicked on the a voxel thing that I could add or remove voxels. So the chunk is gonna be tagged as a chunk. Okay. It's also static. It's not going to be a moving object. That'll help it speed up this drawing. And now the chunk script, I'm just going to drag and drop it on there, and boom, the chunk script adds on the filter, renderer, and a collider. And here in the chunk script, I could give it a size. So just for testing purposes, I just wanted 3 by 3 by 3, the smallest thing. And I'm going to set the voxel size down from 4 so you can see each voxel in the chunk. The mesh renderer needs a material. Let's give it one. Boom. Okay. Let me see what happens when I press play. I get a chunk, a 3 by 3 by 3 chunk. Okay. And you can see that the inside where wouldn't be visible if the voxel was full size. You wouldn't be able to see the inside. Okay. So that's what the side optimize does. It makes that you don't draw the insides. And if I left that off, you would see the chunk draw the insides. Every voxel is drawn full. You see how the sides are drawn in, right into the middle? But if the sides are full size, you don't see the inside. So I could turn site optimize on, and you'd never know that I didn't draw the insides. See, because the voxel is just complete. Okay, so anyway, that's our chunk, and we could control the size. That was 3 by 3, or I could do 10 by 10 by 10 like it had before, and we get a bigger one. Ba-doom. And where are you? There you go. See, on the inside, you don't see anything, but on the outside, the side that shows, you draw everything. All right, so we take that chunk and let's make it let me press stop. Take that chunk and make it a prefab. So now I have a chunk prefab, and the chunk works. So now I'm going to make a new scene, file, new scene, and this scene is going to be where I'm going to actually make multiple chunks. So I'm going to make a voxel terrain now that I have the chunk. All right, so this is my voxel terrain scene, and what I want to have in it is an empty game object, and this is going to be my voxel terrain. All right, and the voxel terrain is going to be made up of a bunch of chunks. So I'm just going to add a script here that's going to be added for my voxel terrain. So here's my empty voxel terrain object. It's also static. And let's add the voxel terrain script that I made here. All right, so it's going to take the size in chunks, and for each chunk, how many voxels. It needs to know what the prefab is for a chunk, and that's this right here. So let me drag and drop it. The voxel size, if I'm doing optimizing the sides, and if I'm doing perlin on. So first, let me start with perlin. Okay, I'll do perlin on. I'll turn it off. And it wants to know what my player object is that's going to run around on the screen. So right now, there is no player object. I just want to see the voxel, all the chunks get made. So what happened before, we saw one chunk. And in the chunk video, I was explaining that there's only so many voxels you could put in a chunk because a mesh has a limit on how many vertices you could have. It's like 64K. So, you can't go on and on forever making a mesh with millions of vertices. So the way I handle that is I just make a mesh out of a couple of chunks at a time. So here, this was 10 chunks by 10 and 3 deep down. But the, perlin wasn't on and it still did the perlin. Let's see, let me put that there. And let me also do the voxel size smaller. Just want to see the script work first. And press play. All right, so you can see down into the insides of these that there's a couple of voxel chunks here. You see where the walls are? These are chunks. Now, why didn't it listen to my perlin on? Well, now's a good time to go in and show you the script for that. Oh, I never showed you the script for the chunk. So the chunk here initializes a chunk, then it renders a chunk. All right. So here on enable sanity check, position is an integer. All right. So this whole algorithm for the voxels and determining which voxel I clicked, it's going to depend that the position of my game objects are in whole number positions and not in decimal positions like 0.1 or whatever. It has to be whole numbers like 1 or 48 or whatever it is. It has to be a whole number. All right. So first thing I'm going to check when I have a chunk is that that is true, that the position is a whole number. So I have this quantized point function which takes the position, rounds it off to ints, then it compares that to the position to see if the position's in whole numbers. Then I also check to make sure that the chunk, the object that this script is attached to, that the object is tagged as a chunk. And the reason for that is so the add and remove voxels could work, because I check to make sure it's a chunk when I click on it. So our chunk prefab right here, see the tag is a chunk. All right, so initializing the chunk, I don't want to do it more than once. So if the voxels aren't null, then just get out. Otherwise, here I am going to initialize it. So first I have to see how many vertices am I going to have in this chunk. That's the size times 24. And then the UV is the same size, the number of vertices for the UV, the number of indices for the UV and the number of indices for a triangle array. All right, so this is how big my arrays are. And then here I allocate those arrays. And then here I allocate a number of voxel objects from the voxel class so that each one, I could have stored in memory in my chunk script. All right, so now I got to make all the voxels in the chunks, right? So in this chunk, I'm going to make all the voxels. So I'm going to go through X, Y, and Z. It's 3D. And I'm going to get a mesh data object for the current voxel I'm at. And for this voxel, I have the start positions in my mesh array of the chunk because it's actually the chunk that has the mesh filter. The voxel, remember, is not, it's just a class. It's not a monobehavior thing attached to a game object. So the mesh, these are the start positions in the mesh for this voxel. And then what is this? We make the voxel. Basically, this loop is going to go through and actually instantiate a voxel at each position in the chunk. Simple. Then rendering the chunk, we get the mesh object from the mesh filter. We see if there's any sides that we could turn off because nobody's going to be able to see them anyway. And then we set all the data from our mesh data object to the mesh itself. All right, then we recalculate the bounds and the normals. The normals do the light and the bounds do the size. And then we set the mesh filter mesh to the mesh collider. All right, so we could collide into it. And then over here, we finish rendering. So we set ready to true. We only want to do this set ready thing once. So on the first time, for the first render, is ready as false because where is it? Right up here is ready as false. But then now this is the first time we're going to be ready. So we set is ready to true. And we figure out the position of this chunk, its position. And I fire off the onChunk rendered event. Okay, so the syntax here is like saying if anybody subscribed to the onChunk rendered, it won't be null. All right, so if it's not null, then I could do an invoke position. So I invoke the event and I send it the position. So this event here is created here in the helper. See, onChunk rendered is the event name, and delegate is a pointer to a function, chunk rendered. So if anybody's listening to that, boo, we're going to fire off an event and the other scripts could know they could start doing stuff with the chunk. Okay, get mesh. Just make sure that we have a mesh on the mesh filter and the mesh collider, and remove voxel. This kind of checks where you clicked on the mesh of the chunk of voxels, and then it determines what the voxel is and turns it off. Okay. Then after it turns off that voxel data-wise on the mesh, it says render the chunk again so you can see it. And this does the opposite. This gets a mesh that it gets a voxel you want to add, uses the normal, and goes forward on the normal a little bit. This one went backward on the normal to go inside. This one goes forward to go to the neighboring voxel that you just clicked, and it turns a voxel on of whatever the type is you want. Yeah. Set voxel type. Yeah. So this script is on omervision.com, but let's get to it. We're like way into the video. Now we're going to go into the voxel terrain script, like what actually made that terrain that we saw. So here's the voxel terrain script. All right, so we got some public variables that we saw in the inspector here. And now we're going to make a bunch of chunks instead of a bunch of voxels. So here you can see the size. If we're going to do optimization, if perlin is on equals true, which I saw my script wasn't working, we'll fix it when I get to it. Then this is for like the perlin. If the perlin noise is on, that could do the perlin hills. And how hilly it is, the bigger the number, the more hilly. The player, and okay, here it is. So our voxel terrain is made up of an array of chunks. And the chunks is made up of voxels. It's like the knee bone's connected to the L bone. All right. So in the start, we just figure out what our max terrain X and Z and Y are. Okay. What is the maximum terrain X, Z, and Y? How many voxels across is this whole terrain going to be? And then we call init voxel terrain. This just puts the base floor object at the bottom so you don't drop right through the terrain. All right, and here we add a listener to the chunk class so that when a chunk is finished rendering and it fires off that unchunk rendered event, we're adding a listener here to the unchunk rendered event of chunk class. And that happens when the script is enabled. And then when the script is disabled, we take away the listener. You know, clean up after yourself. And then it will call the unchunk rendered, right? That's what this thing's going to do. When unchunk rendered, if you get that event, call this script's unchunk rendered, and right here it is with the position. And basically what I do every time a chunk says it finished rendering, I check to see if all the chunks finish rendering. And if they all finish rendering, then I could actually do step 2 of initializing my voxel terrain. But step 1 over here was init voxel terrain. So if we go to that first, init voxel terrain is right here. First, we allocate our terrain of chunks, which is a 3-dimensional array. All right, so, and then for each chunk in the array, we're going to go X, Z, and then Y's up and down. For each chunk in the chunk array, we're going to figure out the position for that chunk. Then we're going to actually instantiate that prefab of a chunk in that position. And it's going to be a child of the voxel terrain. Okay, so now we instantiated a chunk in the scene and it's in the right spot. Let's get a pointer to the script. So here I get the script of that chunk and I set the voxel size from what they said they wanted it to in the terrain script. And I say if the sides are going to be optimized from the inspector window. And then I just add this new chunk script into my terrain of chunks. Okay, so now it's in the array. Allocated the array, and one by one I go through and I add a pointer to each of the scripts of the chunks. And that's basically what a voxel terrain does. It doesn't actually kick off the rendering. Each chunk will kick off its own rendering. All right, and then that's why we come to this thing that after we had the event fire off, here we check if they all said they rendered and we call after all chunks ready. Then we do the perlin chunk columns and we re-render the chunks to make sure they draw. And now that we have the chunks drawn and the colliders on, we kind of put the player in a position over the terrain. Now I didn't make a player yet, but we'll get to that. All right, so let's just see what we get again here. And come on up, bam. And for some reason I saw that it wasn't listening to perlin on. So that would be in, let me shrink this up again. Collapse definitions. It got to be here in the perlin chunk columns to see if it listens to perlin on or not. And I don't think it is listening to it because here's perlin on. And let me see all the references. Nothing's looking at it. All right, so here's a perlin on variable. And in perlin chunks, I shouldn't even do the perlin chunk columns unless perlin is on. So right here, I could say if perlin on equals false, then just return. Okay, and that will stop the perlin from happening. All right, so let's see if that works now. Now I turn it off, and instead of having the perlin hills, I should just have a terrain of a bunch of chunks. Yep, there you go. Now you can see all the chunks. All right, so that's a fold up thing of chunks. Okay, 10 by 10 by 3 deep. And just to make things simpler, I'm just going to keep it smaller. 3 by 3 by 1. All right, just so we could see it simpler. There we go. That's a smaller one. And I'll make it bigger after we see everything work. So you can see, how there's like 9 chunks in here. And you can see the walls between them, right? And the insides aren't drawn because I have side optimize on. Now, if I turn side optimize off, you could see the voxel terrain, which is a bunch of chunks, and they're all drawn right to the inside. Okay, or to go in, it's just chunk after chunk is drawn. But you don't need to draw them all, so that's why I have the side optimize on. All right, so if that's the way it looked when the side optimize is on and the perlin is off, you could see I have a height of 1, and this is a small voxel terrain. Then if I turn perlin on, it's going to call that function that I just kind of blocked out for a minute, and it's going to give a height to each chunk, so you could see like that. All right, and like you saw, that one had not that many hills. Here I can increase the amount of hills, let's say 3.8, and it will be more hilly. See? So that hill number thing controls how many hills there are. Now, I was showing my voxels a little bit smaller than maximum size so you could see through it, but I think we all understand about the optimization to not draw the inside. So if I set my voxel size up to full, and let me try this at 2, and press play, this is the way it would look as a small terrain. Okay. So what is missing here? Let me explain the perlin thing. So there was another video also that I had in the Omar Vision channel right over here about how to make a perlin hills. Okay, so you can look at that video. But here I'm going to explain it too in this function. Perlin chunk columns. So the amount of columns in the Y of chunk here is 1, but it could be more than 1. It could be 3 like I had it before. So let's see. Now the hills are much deeper, okay? But the hills, they go beyond each chunk size. They go deeper than 1 chunk. They go, like maybe this is a chunk here, and then there's a chunk below, and then some here in the chunk on the top, there's nothing. So when I calculate the height of a column over here, I have to think of all the chunks, 3 chunks up. So Y, each chunk has 10. And there's 3 of them, so that's from 0 to 30 would be the height over here. And I calculate for each column in the terrain a height from 0 to 30. And I use the perlin algorithm so that everything kind of comes out like hills, nice and smooth, instead of just a random mess. All right, so that's something to consider here that made it a little bit more difficult to do the perlin algorithm on this. So first thing I figure is I needed some variables like the percent. I needed the terrain column height. That's the value from 0 to 30 of the height of a column. Then I needed the current chunk. Let me just leave this running so we can refer to a picture. Then I needed the height of the current chunk, and random seed. I don't even think I used that. So bye-bye. I didn't use that yet. Okay, the current chunk that we're in. All right, so what happens here, since I'm getting the height for an entire column, regardless of how many chunks are in that column, I'm going to move through the terrain by voxels, right? So even though this has 3 by 3 voxels on the X and Z, there's 10, this has 3 by 3 chunks on the X and Z. Each chunk has 10, so that's actually 30 by 30 voxels. Now, I'm going to go voxel by voxel across my terrain. So my loops are going to go by voxel. So what I had to do first is multiply the total voxels in the terrain are going to be how many chunks by how many voxels per chunk. I think for this part here, what I'm going to do is I'm going to run the code and we'll see the values and the numbers, how they change. So here I am in the perlin chunk columns. I put a breakpoint right here. I'm going to press play to attach to Unity. And then in Unity, I'm going to run the game. And we should hit the breakpoint. All right. So the terrain size in chunks is a vector 3, and it's 333. And the chunk size in voxels is 10, 10, 10. Okay. So 3, 10, you multiply those together, and the total voxels is 30, 30, 30. So I'm going to loop through all the voxels in the X and all the voxels in the Z. All right. And why am I doing X and Z? I'm doing X and Z because I'm going across the top of the terrain, not down and up in the terrain. That's going to be the column height that we're going to figure out. So here I get the current voxel X that I'm working on, the terrain voxel X that I'm going to work on. And of course, the first one's 0. So if the first terrain voxel X is 0, what chunk is that? And what voxel in a chunk is that? So 0 is easy. It's the first chunk, and it's the first voxel in the first chunk. Now I look across in the Z, and I do the same thing to get the chunk Z and the chunk voxel Z. And now I'm going to do a calculation using the perlin noise algorithm to figure out a random height. So the perlin noise function takes integers. It takes decimal values from 0 to 1 to make any kind of random value to come back at you. If you give it whole numbers, it's going to give you back the same number. You got to give it decimal values to get back random values. So I take the current terrain voxel X that I'm at, the position, and I divide it by the total voxels, and I multiply it by the hill amount. This one's going to be a whole number of 0. 0. So 0 is kind of boring. Everything's going to come out 0. My terrain column height, the perlin noise at 0, what's that one going to come out to? 14. All right, so this terrain column's height is 14. I'm going to put a breakpoint there because now when I go through each loop. All right, so first thing, so this terrain column, which is from 0 to 30, the total voxels in this column, I'm going to go through all the chunks from the bottom chunk up. Okay, I'm going to go through all the chunks from the bottom chunk up. So first got to get the script of this chunk, get a reference to the script. And now in the chunk, I'm going to go through all the voxels in this chunk from the bottom up. All right, so now for each of these voxels in this chunk, there is a chunk voxel position, but then there's a terrain voxel position. So this is what I do to get this translation to a terrain voxel Y, which this one's easy, it's 0. And then is 0 higher than the terrain column height? It's not. So I'm going to actually turn on that voxel, and I'm going to turn it to dirt. So I keep going through this loop until finally on this chunk, I'm going to get to column height is 14. So all the terrain voxels that are higher than 14 get turned off. And the ones right at 14, I'm going to turn them into the grass, and the ones below, I'm going to turn them to dirt. All right, so that's the first XZ column that I did that for. Now, if I press continue, now I'm on 0 and 1. And the terrain column height there is 14 again. That's okay. Let's go to one that's not 14. 14 again. Why? And run. If it's 14 again, I'm gonna freak. Ah, 13. Okay. So, the values change slowly in the perlin, and it does depend on how many hills I have. So now I'm still at 0. I'd like to get to, well, this is how it goes. Okay, so this is how this algorithm goes. I'm going to take out the breakpoint. What did I have going on over here? And that's how we get the hills. So that is great. Now we got to make a little player to walk around on the terrain and, click off some voxels and put on some voxels. So let's make a player. Um, we'll just use a capsule. And we won't worry about his position. We'll give his position. Then we just got to add a script here. So we'll call it, I'll just call it player. You're a player. And I'll call this player too. Yep. We'll put this on there, y'all. Come on, Bubba. Get on there. All right, now I think I need a rigid body. Physics, rigid body. That way, you could like land on the ground. And just so my little capsule guy doesn't like fall over, I'll just hold the rotation on the X and the Z. All right, so now I'm going to write the script to control a player. So, sorry, I just did magic on you guys. Here's the whole script. All right, so to control a player, I want to make sure I have a rigid body, just in case I forgot to add one. The script will add one for me, so the player could like drop to the ground. And this just has the mouse buttons. All right. This is how fast my player is going to move, how fast he's going to turn, how fast she's going to jump, how high she's going to jump. I need a pointer to the camera so I could tell where I click in the scene, and I need a pointer to a rigid body so I could jump. So in the start, I get a pointer to the rigid body, and I put the camera in the middle of my player, okay, so that the camera is inside my player and I'm seeing from the player's eyes. Then I lock the screen. I lock the cursor to the game screen, so you don't see the mouse moving around on the screen when I'm moving the player in the game. Now in the update function, I check for all the player controls. Since I locked the mouse cursor, I have that if you press the escape button, you get back the mouse cursor. Then WASD is to move the player around on the ground, left, right, forward, and backward. And then I use the mouse. I read the mouse. If you move the mouse, I rotate which way I'm looking. And if you have the camera, I could look up and down. So I can look side to side and up and down. Then jumping, I just add force to the rigid body. Okay, and jumping's with the space bar, and I don't really need that anymore. And then here's the cool part. I'm interacting with the voxel terrain over here. So if I press the mouse button, if I press the left mouse button, I'm going to add a voxel. If I press the right mouse button, I'm going to remove a voxel. So I'm going to call these two functions add and remove voxel, right? So how do I know what to add and remove? First thing, let's do add. So add, I'm going to take a ray that goes from the camera to the mouse, and I'm going to use physics raycast to cast that ray into the scene and see if I hit anything. And I'm only going to go as far as 3 units. So I can't click on something that's too far away. It has to be 3 units close or closer. And then this is where I made sure that the tag was a chunk for what I'm clicking on. So that's why we had to make sure our chunk prefab had the chunk tag, because here when I click, I make sure that the thing I hit is a chunk first, and then I call the chunk script add voxel, and I just pass it the hit information and what type of voxel I want to add, a stone. And then over here with the remove, I do the same thing basically. I make a ray from the camera to the screen, I see if that ray hits anything, and then I do a transform comparison to make sure it's a chunk, and I call the scripts the chunk scripts, remove voxel, and pass it the hit. So now I got a player or a player script, and now I'm going to be able to give the voxel script who the player is. Now the reason the voxel terrain script wants to know who the player is so it could put the player over the voxel terrain. You don't know where that is until the voxel terrain is made. So just let the script put it there. I'll say play. So now the player should go over the script, but something happened. What happened? See player. I think I could control the player. And the voxel terrain player. Yeah, so what's up with this voxel terrain? Let's see. And the init voxel terrain. Here, okay. And then that's perlin chunks. And okay, here's after all the chunks are ready, after the event. If player not equal to null, transform position. Let's put a breakpoint there to see what happened to my player. Press play and press play here. All right, so we got here. That's good. And it's not null, so it should come in. And the player position right now is that. And now the position is that. So, okay, so position the player. That's good. Wait, did it ever put the camera as a child of the player, though? I don't think so, because here, the camera is still here, and here's my player. Okay, so my script didn't do that. Let me do that. Let me take the camera, player, and then put the camera as a child, and then I just reset it. So you see now, the camera is inside the player, and I want to see from like the top of my player's head, like that, okay? So that's about the top of my head right there. Save. Now I think things will figure it out here. All right, there we go. Oh, and here I am. I'm a player and I'm inside, but my mouse didn't lock in. Why? Why didn't my mouse lock in? I didn't press escape yet. So let's see what's up with that. There's always something wrong. Here's the player. And outline collapse. Start. Needs a camera. All right, so here's my player script, and the camera's still null, so let's just tell it this is the camera. Anything else missing now? Let's press play. Player drags and drops, and there he is. And the player can move around. Can I? Ooh, yeah, I can add. I could remove voxels. Can I add them? I can add voxels. Good. All right, now let's see something else. It's kind of dark. Let's give the player a little light. So let me add a light to the player. So point light with a range of 10. Let's make it a range of 5, just a little bit more than the 3 range that I have that I could click. And let's make the light like a natural light color, like a flashlight. All right, file, save. And let's see, play. Yeah, I need a flashlight because it's gonna be getting dark when I go into those holes. Like, look at this hole. Could barely see anything. I probably could even make the light a little bit stronger. Well, that's why Minecraft has those candles, isn't it? If I press jump, I could jump up and see more of the terrain. All right, cool. So my player's moving. There's only one thing. It's kind of hard to tell where I'm clicking if I don't have a little target. So to make a little target for me to say where I'm clicking, I'm going to add a UI text. Okay, and here is the text. This is going to be my little X marks the spot. So I'll put an X there. And the color, the size of the X it's right there. I want it to be centered. So I'm going to hold the Alt key and click this. Alt, click this here, and I'm going to say center. And you're like, that's not the center. Well, that's because we have to do this. And we have to do this. And now that's the center. So there's one X right there. Let's make another. So this is a target. I'll just create target 1. Let's make a duplicate of that so we could have it in black and white. Target 2. And target 2, I'm just going to move it over slightly, like -1 and -1, and I'm also going to change the color of it so we could have a contrasting color. So maybe this could be -2 even, looks better. And -2. Now there's a little X marks the spot for the center of the screen. And I'm just going to tidy this up. I'm going to put the event system in the canvas. All right. File, save. Now if I press run the game, this little X will be my little target marker, see, for where my mouse is pointing. And now when the X is on something and I click, I know I'm removing that voxel. Okay, I know I'm removing those voxels. And if I press the other button, I know I'm putting stuff on. Now I'm drifting a little bit here. My player is drifting a little bit. So I could do something about that. It's probably because when I hit objects, there's like a collision, and I'm just going to increase the angular drag. All right, so when I hit things, it doesn't make me start spinning. File, save project, and run. And we're almost, there we go. All right, so say it's like still too dark. I want it to be a little bit brighter. I could just increase the range of my light or the intensity of it. My player has this little light, so I can increase the range to 8 maybe, so things shine up a little bit better. Yeah, that's a little better. See, now I'm in the hole, but I could see a little better. And yeah, so now basically the things are working, right? And now with the terrain, I could just make it as big as I want. How big can I make it? I don't know, but let's try 10 by 10, like the way it was in the beginning. So here's 10 by 10. Takes a little longer for it to calculate everything. And there we are. Let's see how that looks from the sky. Oh, now that it's bigger, those 4 hills that I had, they're kind of spread it out. And almost looks like somebody did a little meteor crater. But I could play around now, trying to get like the kind of hills I want. I could say 15 by 15 to make it bigger. I wonder if I can go to 20 by 20. I don't know. Dun-dun-dun-dun. Bigger, it takes longer. And boom. Let's see. Yeah, nice, nice. And I could dig into the ground. I have a little light bulb on me. Oops, that's not digging in. Now, of course, it's showing the stone when I click because that's what I have in my add voxel. I say to add a stone. I could change it to add something else. If I go to my player script here, and when I say add voxel, here I said it was stone, but I could say whatever I want, really. Well, let me just stop the code. I could say whatever I want. I could say dot coal, dirt, grass, lava. Let's see what lava looks like. And save that. So I think one of the next things I gotta do is make a little inventory thing at the bottom so I could pick what type of voxel I want to add. Because right now it's kind of hard coded. But here we go. And if I add a lava, there you go. Lava, 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 lava. And I could just keep jumping. I just press the jump button over and over again. And it's like I'm flying. All right, so finally, there you go, guys. That is it. Please just go to the Omar Vision website to go to the tutorial section. And this video I just made should be showing up right here. And if not, you'll just type in the search word voxel and search, and I'll just bring up all the videos about voxels and show them instead of all 136. Okay, or anything you want to search for. Like we had the event thing, so you can search for events and see anything that has to do with events. But that's how you could find the video. This one is going to be showing up here as soon as I publish. All right, guys. Thanks a lot. See you later.